Hi there, welcome to edupediaworld.com. You're watching the videos on probability, right? So in this video we'll discuss some more questions related to examination which are generally seen in examination, right? So you have to watch this part of the video very carefully again. So let's get started with the first question, which is question number 1. Now the question says that in a particular section of class 9, 40 students were asked about the months of their birth, and the following graphs were prepared for the data so obtained, right? So this is the graph for the, let's say, the month they were born, and these are the number of students, and these are the month as represented in the bar graph. You can see very clearly, right? Now we need to find the probability that a student of the class was born in August, right? So we need to find the probability, right? Now so let's see how we can solve this question. So if you can see the bar graph clearly, we have August bar graph over here, right? And it clearly represents 6, you can see. So we can say that number of students born in August are 6, right? So we can say that the probability that a student of the class was born in August will be equals to number of students, right, born in August upon total number of students, right? So this will come out to be, you can say, 6 by 40. So if you simplify, this will come out to be 3 by 20. So this is the probability that the number of students are born in August. So this is how we have to solve the question, by looking at the bar graph. So let's move on to the next question, which is question number 2. Now the question says that we have the following marks, and these are the corresponding, we can respectively, or corresponding, we can say, the number of students. And the first part says that we need to find the probability that a student obtained less than 20% in the mathematics test, and the second is find the probability that a student obtained marks 60 or above, right? So let's see how we can solve these questions. So let's solve the first part then. Now we need to find the probability the student obtained less than 20%. This means the marks should be less than 20 because the marks are out of 100. So we can see clearly, so this group or this class represents the marks from 0 to less than 20, because whenever we have a group class, we don't consider the upper limit, as we have discussed in the chapter statistics, right? So this means the number of students that obtain the marks less than 20% in mathematics are 7, right? So this is how you have to interpret the information from the graphs or bar graph or the group frequency data, whatever it is given, right? Now we can write over here the number of students obtained, right, marks less than 20% in mathematics are 7, right? So we can say that the probability that student obtained marks less than 20% will be equals to number of students obtained marks less than 20%. So these are 7, so we need to write 7 upon on total number of students, right? So this will be equals to 7 upon 90. So this is the probability that a student obtained marks less than 20%, right? Now let's do the second part. Now the second part says find the probability that a student obtained marks 60 or above, right? The student should obtain marks 60 or above, right? So if you see this class, it says 60 or 70, 60 to 70, the number of students are 15, and this class says that 70 or above, the number of students are 8, right? So this means we have to consider these two classes because the question asks the marks obtained 60 or above, right? So we can say over here number of students who obtained marks 60 or above are 15 plus 8, so this will be 23, right? So we can say that then probability that a student obtained marks 60 or above will be equals to 23 upon total number of students, right? So this will come out to be 23 upon 90. So this is how we have to solve the question, right? So let's move on to the next question, which is question number 3. Now the question says that the distance in kilometers of 40 engineers from their residence to the place of work were found as follows. Now so these are the distance of the 40 engineers, they traveled from their residence to their work of place. Now we need to find, the first part says that the distance should be less than 7 km from her place of work, and more than or equal to 7 kilometer from her place of work and within half a kilometer from her place of work, right? So let's see how we can solve this question, right? Now first part says that the distance should be less than 7 kilometer, right? So let's see how many are there. That's a 1 2, right? Then we have 3, then we have 4 5, then 6, then we have 7, then we have 8, then we have 9. So there are 9 engineers, we can say, right? So we can say that the probability the distance is less than 7 kilometer is 9 upon total number of engineers. So total number of engineers, so this will come out to be 9 upon 40, right? So this is how we have to solve the first part. Now the second part says that more than or equal to 7 kilometer from her place of work, right? So it should be more than or equals to 7 kilometer from her place of work. So if you can see very clearly, we have 9 engineers, the distance is less than 7 kilometer. Now they are asking how many engineers, let's say number of engineers who have, or let's say who travels, we can say, and we can write anything, distance less than, or we can say that more than or equal to 7 kilometer, right? So how we can do it, let's say we have 40 engineers overall, let's say we have 40 engineers and we have 9 engineers who have distance who less than 7 kilometers. So we can take away 9 over here, so this means this will come out to be 31. So this means we have 31 engineers who have distance more than or equals to 7 kilometer, right? So we can write 31 over here, we need not to count, so it can save your time. So we can say that now the probability that distance is equal to or more than 7 kilometer will be equals to 31 upon total number of engineers. So there are 40 engineers, so this is 31 by 40. So this is how we have to solve the probability. Now the last part says that within half a kilometer from the place of work. So within a half kilometer, any distance we have less than 2? No. So this means for the third part we can write, so number of engineers with distance within, or we can say within half a kilometer distance, right? So there are 0 engineers, so we can say that the probability that distance within half a kilometer will be equals to 0 upon total number of engineers. So these are 40 engineers, so this will be 0 upon 40 and the probability will be 0. So this is how we have to solve these type of question, right? So let's move on to the next question, which is question number 4. The question says that a study was conducted to find out the concentration of sulfur dioxide in the air in the parts per million ppm of a certain city. The data obtained for 30 days is as follows. So this is the data for 30 days, right? Now we need to find the probability of concentration of sulfur dioxide in the interval of 0.12 to 0.16 on any of these days, right? So we need to find the how many values. To be very straightforward, we need to find the values, how many values lies between this interval, right? So let's do it quickly. So let's say we have interval 0.1 to 0.16, right? So we need to count the values. Now which values we have to consider, it should be 0.12 or less than 0.16. So you have to be very careful how many which values can come into this interval, right? So you have to be very cautious, right? Now from the first line, or we can say the first row, we have no value, and from the second row we have no value, and from the third row we have one value, right? Second, then from the fourth row no value, we have from the last one is 0.11, and then any other value can come if you can see properly, right? You can recheck it again. So 0.13 can come, right? So it lies in between 0.12 to 0.16. Any other value, right? So there is no other value. So this means 0.12 to 0.16. So number of values, or we can say that number of days we can write are, it's 1 2 3 and 4, right? Now we need to find the probability that concentration of sulfur dioxide in the interval of 0.12 to 0.16 will be equals to 4 upon total number of days, so it will be 4 upon 30, right? So when you simplify it, so 2 ones 2 15, so this will come out to be 2 by 15. So this is how we have to find the values, or we have to solve these type of question. Now let's move on to the next question, which is question number 5, and it's also a last question of this video. Now the question says that the blood groups of 30 students of class 8 are recorded as follows. Let's say these are the blood groups of 30 students of class 8 as recorded as follows. So let's say we have A, B, O. So these are the blood groups. So we need to determine the probability that a student of this class selected at random has a blood group AB, right? So we need to find how many are there with a blood group AB, right? So first of all, we need to find the students. So we can say the number of students with blood group AB. So let's see how many are there. So we have 1, right? We have 2, we have 3, right? So we have 3 number of students, right? So we can say that the probability that a student of this class selected at random has blood group AB is number of students with a blood group AB. So these are 3, and we can say upon total number of students, right? So this will come out to be 3 upon 30, right? So when you solve it, it will come out to be 1 by 10. So this is how we have to solve these type of question. So in the end, I can say that thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.